So today we'll try to understand why divergence of magnetic field is 0. Okay, so why del dot B is equal to 0. Okay, so this we'll try to understand, right? Okay, so what is B? B is here the magnetic field. Okay, so B is nothing but my magnetic field. Okay, so we call it magnetic flux density, right? Okay. Now we know that this first in last class we have seen that whenever any charge is static, okay, so whenever a charge is static, suppose this is a positive charge, okay, so whenever a charge is static, so it will produce some sort of electric field. So it will start from the positive charges, it will terminate to the negative charge. Okay, so this is how we have seen. So this is the negative charge. So this is how the field will exist, right? Okay. So this is how this electric field is going to exist. Okay, whenever any kind of static charges are producing some sort of electric field, so this field is also static. Okay, we will get here electrostatics. So this is not varying with respect to time. But whenever these static charges will start to move, okay, means whenever this static charges is going to move, so how they will move? So obviously it's going to move through a wire. Okay, suppose if I am taking a wire, okay, whenever a charge is moving through the wire, so what I am going to get? So I am going to get a current. Suppose this is the direction of current, right? So this is the direction of current, I. So whenever the charges are going to move, so this particular charge suppose is moving, okay, moving in the upward direction. So I'll be getting the if this is due to the positive charges, so obviously I'm going to get, and charges we know that due to the flow of electrons, so electron will be flowing opposite to the current flow. So in this particular direction, suppose the current is flowing, right? So due to this current flow, I'll be getting some sort of magnetic field. Okay, so I'll be getting some sort of magnetic field. Okay, so around the this wire. Okay, so around the wire the magnetic field will be created. Okay, so for better visualization we can see the 3D picture of this magnetic field. Okay, so from here we can see this particular picture for better visualization that how exactly the magnetic field really looks. Okay. Suppose in this particular direction the current is flowing. Okay, so this is the direction of current flow I. So then, so around the wire, so this is how the magnetic field will be created. So this is how the magnetic field will be created. Now what will be the direction of the magnetic field? So you can simply use the right hand thumb rule. Suppose this is the right hand, okay, and this particular thumb is basically pointing the direction of current. So as your current is flowing in the upward direction, so here you can see that we have considered the current is flowing in the upward, so your thumb will be directed toward the upward, and the curl of your fingers, right, the fingers, in which direction the fingers are curling. Okay, so these particular fingers are basically curling in this particular direction, so this direction will be your magnetic field direction, right? So you can see here the magnetic field is directed towards the curl of the finger, right? So the direction of our fingers are curling, so to that particular direction the magnetic field will be created. So here also you can see, right, if the current is flowing in the downward, your thumb will be downward, so obviously direction of the magnetic field will be reverse. Okay, so this is the direction of your magnetic field. Okay, we can determine using right hand thumb rule. Okay, so this is basically your right hand. Okay, right hand rule. Okay, so right hand rule you are going to apply to find out the magnetic field direction, right? Okay, now if this charges are moving with uniform velocity, okay, right, okay, if the charges are moving with uniform velocity, or I can say that if this current is a steady current, right, okay, so this is a steady current, or I can say that if this current is produced due to some DC power supply, right, okay, then due to the flow of steady current, whatever the magnetic field I am going to get here, suppose whatever the magnetic field or magnetic flux density I am going to get here, okay, so this will be a time independent, or I can say a static magnetic field, right? Okay, so due to the steady current, so I'll get static magnetic field, right? Field means this is basically your magnetostatics, okay? Okay, magnetostatic. Now, if this current is produced due to some AC supply, right? Okay, means this is a time varying quantity. If the current is varying with respect to time, then this magnetic field will also be varying with respect to time. So here I will get then BT. So a time varying magnetic field I am going to get, right? Okay, so this is how the magnetic field will be produced due to current flow, right? Okay. Now we know that the divergence of this magnetic field, if I look at the divergence, okay, the divergence of the magnetic field is 0. So divergence of magnetic field, okay, so we have seen that. So divergence of the magnetic field is 0. So we are trying to understand why this quantity is 0. Right? Why this quantity is 0. Okay, so we'll try to understand that. Okay. Now, what is the physical significance of divergence? So, we'll try to understand first, okay? Physical significance. Physical significance. So, what is the physical significance? What exactly the divergence is giving you the information, okay? Now, as we are finding out the divergence of the magnetic field, okay, so this is the divergence of the magnetic field. So, divergence is giving you the information, okay, suppose this is the magnetic field, suppose this is the magnetic field, okay, so this is the magnetic field, right, okay, it is forming always a circular loop, and divergence of B is 0 means it will also give you the information that magnetic field will always form a circular loop. Now, what exactly divergence means? Suppose for any vector, if I want to find out the divergence, suppose this is a vector quantity, and I want to find out the divergence, just like your magnetic field. So this I can say any kind of vector. So say the vector is A. Okay. So if I am considering here a unit volume, okay, suppose here I am considering a unit volume, right? Okay, so a unit volume I am considering. Now the divergence, if I want to find out the divergence of A means that, so divergence is giving the information that what is the net quantity of vector which is coming out from this unit volume, okay. So net vector, okay, so net quantity, okay, of the vector is coming out, okay, from the volume, the unit, so volume, right? Okay, means here I can say that to this particular unit volume, the vector quantity which is entering, that is basically A, okay, and with the same magnitude it is basically coming out. So what is the net quantity of the means the vector is coming out, so coming out vector quantity is A, entering vector quantity is also A. So here the net quantity is 0. So for this particular vector we want to find out the divergence. So divergence of say A, so this will be 0, which is a scalar quantity, right? Suppose this is a same vector A. Now unit volume, suppose if I am considering at the origination of the vector, suppose here from the vector is originating and here I am considering this unit volume. Now here if you look at, now nothing is entering to this particular unit volume, so input quantity is 0, but the quantity of A is coming out from the unit volume, right? So from here the vector A is coming out. So input is 0, vector A is coming out. So what will be the divergence? Divergence will be a positive quantity, right? Okay. So here the divergence of A will not be 0. Okay. So this quantity is not equals to 0. So net amount of vector which is coming out, that is A. So this is a non-zero quantity. Now here I will get a positive divergence. So it will be positive divergence, right? Okay. Now similarly, if you come at the end of the vector, suppose the vector is terminating here. So you can consider the case, suppose this originated electrostatics, right? So this is originated from the positive charge, and this basically or terminate to a negative charge, right? So this may be your electrostatic field. Okay, so for electrostatic field, suppose if I am coming at this particular point of what I can say, where the field is terminating. So here if I am considering unit volume, so here the field E is entering. Okay, now how much quantity of field is coming out from the volume? Nothing. Okay, the quantity which is coming out from the volume is 0. So here, so what is the net quantity? Is input is E, output is 0. So you will be getting some sort of value, but it will be negative. So here you are going to get a negative divergence. So you are going to get a divergence but a negative quantity. But in between of these two field, okay, if you are finding out any unit volume, okay, then this quantity will be 0. Okay, so that is the reason that your divergence of E, okay, divergence of is maybe 0 at this particular point, okay, between the origination and the termination point. But if you are coming at the originating and terminating in, it is a non-zero quantity. That's why the divergence of E is not equals to 0. So divergence of E will not be 0 always, right? Okay, so this will not be 0. But if you consider the divergence of magnetic field, okay, now here as the magnetic field is forming a circular loop, okay, so as I have seen, the magnetic field is basically forming a circular loop. Now here if you look at, so here if I am considering unit volume, suppose here I am going to consider a unit volume, right? Suppose here I am going to consider a unit volume. So what I can see here, so the amount of magnetic field which is entering, this is B, okay. Now the amount of magnetic field which is coming out, that is also B, okay. So what is the divergence of B? So divergence of B will be, equals to 0. Now you take any point over the magnetic line of forces. Suppose if you are taking any point, okay, so if you are taking any point, everywhere whatever the amount of magnetic field is entering, same amount of magnetic field will be leaving. Okay, that's why this is only possible when the field is forming a circular loop. So you take any point, okay, so if you are taking any point, okay, you'll see that amount of magnetic field which is entering, the same amount of magnetic field will be leaving. Okay, so that's why in case of your divergence of 0 means the field is basically forming a circular loop. So this is 0 only possible when the field is forming a circular loop. So that is the reason the magnetic field is forming a circular loop, which signifies del dot B is equals to 0. So this is all about the divergence of magnetic field and its physical significance. Thank you for watching, and please subscribe my channel if you like my videos. Thank you.